In this video recording, we're going to demonstrate how to merge two surface models, the first being an RTK GPS-derived surface model of roadway, centerline, edge of pavement, and shoulder information as shown here on the screen, into a LIDAR-based surface model that was established from the state of Iowa. So to get a quick overview of our surface models, we're going to go ahead, and I've already built the two surface models utilizing the Iowa Regional Coordinate System zone, and I'm going to go ahead and take a look at the two surface models. So underneath my View menu, I'm going to go down to my 3D viewer, and we'll take a look at the Surface 3D Viewer command. We're going to go and grab the RTK GPS data surface model of the roadway information itself. And again, as we take a look at this model, we can sort of see that this is, again, just roadway centerline, edge of pavements, and shoulder. And we've got our elevations established. And what we would also like to do now is take a look at how the underlying LIDAR surface model is relative to this data set. So we're going to go to the Model tab in the 3D viewer. We'll right-click on the surfaces and we'll add a surface, and in this case we'll add in the LIDAR surface. And we open that up, and we now actually have two surface models sitting on top of one another. And if I use the clipping plane control down here at the bottom of the screen and move it along the bottom, you'll start to see it slice through the models. And it's sort of hard to pick out here real quick, but you can just see that my roadway model is just slightly above the elevation data of the LIDAR model. So what I want to do is to merge these two things together is I would like to create a series of slope projections from the shoulder edges of my roadway model to the LIDAR model at a presumed 3-to-1 slope. Very common slope for four slopes on roadway designs. So what we'll do next then is make that new surface model that will have the daylight lines so that these things will tie together. So I'm going to exit out of my Surface 3D viewer. And in my current drawing right now, I have a 2D polyline that represents the boundary of my surface model. What I'm going to do is I'm going to get rid of that polyline boundary, and actually we're going to draw in the surface model boundary of the tin that I have built, namely the GPS tin. So if I go to my Surface menu, I'm going to come down to Draw Surface. I'm going to say Draw Surface Boundary. And again, I'm going to put this on my Survey Topo Boundary layer, and I'm going to draw this in as a 3D polyline now. I'll just choose OK. And the surface model boundary that I want to draw back into my drawing is that of the GPS model. So now that I have the data in a 3D polyline format in here, I can now go through and develop some slope projections down to the LIDAR model. So I'm going to go back to my Surface menu. I'm going to choose the Design Pad Template Routine. And I'm going to say the source of the target surface model will be a surface file itself. We're going to go to the outside, and we'll just take all the rest of this information here is pretty much all okay. And I'm going to go ahead and put in I guess, yeah, everything is good. So we'll just click on OK. And the pad polyline, or the boundary polyline in this case, is that of the original surface model. And we are going to project that to the LIDAR surface model. And we will presume that we're going on if we're in a fill slope, we're going to, or in a fill condition, we're going to go out at a 3-to-1 slope. And if we're going to happen to be in a cut scenario, we also just choose a 3-to-1 slope, and we'll go ahead and press enter on that. And the slope projections will then be put into the drawing. It'll ask us if I want to adjust the parameters and redesign the pad. In this case, we'll say no. And do I want to contour this? I'm going to say again, no. And what I want to do now is to create a brand new surface model of both my GPS data and these slope projections. So I'm going to go back to the Surface menu. I'm going to say Triangulate and Contour. And in this case, what I'm going to do is create a brand new file name in here, and I'll call this the Highway 52 IA GPS, and I'll say to daylight. And we'll go ahead and hit save. And again, everything else in here, we're going to use the inclusion perimeter value, which will be the boundary of the slope projections now. Again, we're not going to contour this, and we don't need to worry about labels. And again, I don't need to worry about my selection options in here. So I'm just going to go ahead and choose OK. The perimeter boundary will be this polyline boundary right here. I don't have any exclusion areas, so I'll just press enter for none. And then what is it that I want to make a surface model of? I'm going to say all entities that are on my screen. Okay. Now, we found a few little break line areas that we might need to be concerned about. Well, in this case, we have one T-intersection at 0.04 of a foot, not really worthwhile worrying about. And again, I have some vertical edges, 0 shown, which means that those errors are below my 1,000th of a tolerance that I had set for my surface model Explorer settings. So basically, my surface model is completely fine. So I'm going to exit out of my error here, and then we're going to go ahead now and actually combine the two surface models together to form one overall composite surface. To do that, I'm going to switch into Carlson Civil. So I'm going to go underneath my settings menu, down to Carlson menus, and I will choose Carlson Civil. And we're going to go underneath the surface menu, and we're going to choose the triangulation file utilities. And inside the triangulation file utilities, I'm going to load a source tin, which in this case will be my LIDAR based surface model. And then we'll choose next. And to that, we are going to merge a tin. And the second tin is completely inside the first one. So everything else in here is good. We'll just choose OK. And the second model that I want to merge in will be the GPS to daylight surface model that I just built. So the software is going to go through then and combine both these two surface models together. And as we take a look, we can see we have the LIDAR-based data here on the outside, the GPS data based here on the inside. And once these two models have been put together, we're just going to go ahead and say Save as tin. And I will call this Highway 52 IA, and I'll say merged. That new tin file has been saved, and now I can then use that surface model for further cross-sectional analysis for my roadway project to come. So that concludes this presentation on how to merge two surface models together to form one overall composite surface model. Thank you for your time.